everybody. So yes, I'm Paul. I'm a developer advocate. I work at Google. And right now I'm working mostly on app accelerated mobile pages. But my team in general is working on improving the mobile web and improving the web in general. So we work on Chrome, we work on AMP, we work on PWAs. And so this talk actually bridges those two topics. And hopefully quite easy. Alright, the web is, what is the web? It's cross-platform, it's indexed, all the versions, composable, evergreen, linkable, limitless, secure, easy to deploy. All of those are things that I love about the web, that I think are core characteristics of the web, that make it really, really great. And so this is why I fell in love with the web in the first place, why I started the web. Why isn't anyone building the web? I mean, all of those things are really nice titles. But the problem is that the current web, especially the mobile web, looks like this. It's slow loading. There's non-responsive content because there's so much ads and analytics going on. And content is shifting around all the time, right? You probably know that problem. You load a page, and then you start reading a paragraph, and then some obnoxious ad or some image pushes the content down, and you need to start reading all over again. Super annoying. I personally hate that a lot. And the second problem why everyone is not building the web today is missing device calibrations to improve engagement with those experiences. So the web is great for ephemeral experiences when you come to a search engine, search for something. But for engagement, people want to have stickiness, home screen access, all of those things, push notifications. And so that too is a problem in some ways, but it has been mostly a problem for a long time, which is why people build native apps instead. So let's talk about the mobile web, right? Because the mobile web is really slow, even slower than the other web, which I call the desktop web. But I'm going to go one level higher than that, and I say, let's talk about content sites on the mobile web, which is basically a turtle on a turtle. So by content sites, I mean, you know, BuzzFeed, Washington Post, and I'm not trying to single out anyone, right? But all of the sites that publish content, any kind of WordPress blog, all of the links that you would click on if you come from platforms like Facebook or Pinterest or Twitter. Those are content sites. Why are they so terrible? Well, let's look at some statistics. We all know time is money. This is one report that was released by Suaza to show you bounce rates when it comes to performance. But I have an even worse one, which is this one that we just recently released, a double-check study that shows that after 3 seconds, 53% of all users will bounce, meaning they will load your page for 3 seconds and then they will click away. So think about that. If your site loads, and that's on mobile, right? If your site loads longer than 3 seconds on mobile, which is basically everyone, you're going to lose half of the audience. And still, performance is usually not prioritized to most companies. And the problem is actually worse. If you look at the full study, you see, on average, about 214 survey requests per mobile web page. 19 seconds is actually the average mobile page load time. And 77%, you could say, you know, average. Yeah, average doesn't mean anything. But 77% of all mobile sites take longer than 10 seconds to load. Now, coincidentally, 10 seconds is the threshold where 100% of your users jump off. So those pages will never have any visitors. And the crazy thing is that 50% of those requests are actually ad-related. It's just horrible. So how do we fix that? Well, the web developers in this room, how many are web developers? Can you show the guy? Yeah, almost everyone. Okay. The web developers in this room, and this is great. The web developers in this room probably know some things to fix performance. You know, the trivial stuff like, hey, how about no megabyte-sized images? Or no render blocking ads? Or how about no 100K lines of JavaScript? All of those things make a lot of sense, and you're like, Well, yeah, no, I'm not dumb, right? I mean, I've done that stuff for a long time. Well, are developers just stupid? Is that the reason? Well, not really, no. It's because after this, everyone expects everything on the internet to be free, right? There's no built-in monetization model from the ground. So what publishers did was to recreate the same model they know from newspapers. So they went to ads. And unfortunately, the publishing industry was desperate and hungry, and some built up very unhealthy relationships with both the users and the monetization method. And so our typical situation in that context is this one, where you have the manager and then you have the developer, and so the manager is desperate, and he's like, I want that new beacon, I want that new ad tag, I want that new library. And what can you do in that situation? Right? He's your manager. There's nothing you can do. You know about the best practices of web development, but if he wants that ad library, he will get that ad library. So in the end, you end up with this perfect conflict of interest. Content versus ads. User experience versus monetization. So publishers are desperate to attract and monetize users and prioritize it above all than user experience suffers. So this problem gets even worse on the web. Because with HTML, CSS, and JavaScript, you can do pretty much everything, right? We don't really have a lot of sandboxing going on. And so third parties and advertisers really do everything they want. If you load this script tag, they will go wild. They will do whatever they want on your page. Render blocking scripts, all sorts of things. So it's like giving 100 random strangers the keys to your apartment. I mean, what could go wrong? So to visualize this, a pretty cool dude named Brad Frost has built this page called Death to Bullshit, perfectly fine HTML page, right? But if you turn on the bullshit, it becomes a normal web page, essentially. But even mobile, that's power. So basically what we're using, right? I mean, you all have seen those pages. Yeah. So what are some solutions that people have come up with to fix that problem? Well, first one is aggressive ad analytics and speaking blockers. The second one is content distribution platforms. The first one doesn't work, but they dramatically harm publishers on it. So at some point, the site goes down and the message says, this is why we can't have nice things. But now the second one requires a contract between the platform and the publisher and lock you to a specific platform. They partially work, but are major hassle to maintain, and they don't really embrace the qualities of the web. So they build their own sites. They don't really seem like legit solutions to the problem, in our opinion. And please don't do that at home. It's not good. So I think we should go one step back and really think about the ideal user journey. What is the thing that we want to build in the first place? And we've come up with this fake website that visualizes that journey for us. And so what this is here, you start with a search, you land on an e-commerce site, you click on it, and yeah, this is probably what I want. And then you explore the category, pick your favorite from that. It should load really, really quickly, right, because of the 3-second counts rule. You look at that, and then, oh no, it's out of stock. So what do? Oh, there's a reminder down here. So I click on it and say, yeah, remind me when it's available again. So then it asks you to allow push notifications right when you need it, so you probably agree to it because that's what you want, right? And then you stay up to date. Now, at some point, you forget about it, you go into a tunnel, but you want to browse again. The user loses the connection because they enter a tunnel, and then continues exploring because everything is available offline, magically, like with any native app, even with no reception. And then at some point later on, a couple days afterwards, they get a notification natively in their push notification center on their device, get notified by the website, even though the website is not open anymore. They then add it to the cart because that's what they wanted. Check out the basket, get signed in automatically because they signed up before, so why enter the password again? And then it's one tap to pay. One tap, and then because the experience was so awesome, and I want to explore more, and I really like that store, I'm going to get a prompt, say add to home screen, yes, add to home screen. So I'm adding it to my home screen. I can then access it again with ease. It's going to load really quickly because it's already available offline. And you can re-engage on it. That, to us, is the ideal user journey today. Now, of course, this is an e-commerce example, but the same kind of system works in various verticals. So it works in e-commerce, it works in publishing with some modifications. So how do we do this? The solution to this problem, number one, what we need here is a baseline entry point that needs to be fast. It needs to be easy to implement. It needs to be mobile friendly, of course, embrace the open web, and enable monetization. That sounds like a crazy unicorn, I know, but we've done something that I think works, and that's AMP, short for Accelerated Mobile Pages. So AMP, in a nutshell, is a way to build beautiful, highly portable, high-performance mobile web pages. Web pages in general, not just mobile pages, but it's optimized for mobile. It gives you a rich, growing library of components, pre-built components that are easy to use and can be embedded. And so you can show media, live updates, display ads, all sorts of things, core analytics with it. It really looks like this. I mean, it's HTML. You know that stuff. There are a couple of differences though. For instance, you see a tag here called image, and that replaces the actual image tag. And you're probably wondering, well, I already have an image tag. It works, it displays images. There's a good reason why we do that, and it's because we need to be in control of the load pipeline. We need to understand what's happening on your page in order to prioritize the content. The publishing workflows of AMP actually looks like this. So as a developer, as a publisher, in your CMS or outside of your CMS, you create AMP pages. You can then create just one AMP page, or you can create an AMP page that's linked to another canonical website, web page. So you create two versions of it, but you don't have to. And it gets cached by the AMP cache on top of that, which I'm going to explain what that is. And finally, it gets distributed and embedded on various platforms, like Google Search, and then displayed to the user. The ecosystem is actually growing a lot. Every month we get some more people on board. In fact, it's pretty crazy that a Google-led project has Bing on its life, right? But we're actually very proud of that achievement. I think it was amazing because we designed this project to be very open, and we don't want it to be Google's AMP. We want it to be everyone's AMP. So Bing does the same thing that Google Search does with AMP. Now, on the Google side of things, you can see it in the three different things. You can see it in the top storage carousel in search. If you search for anything newsworthy, you will get a carousel, and it will show you the like and bold at the bottom saying AMP. Rich cards in search, news and weather app, and this is actually not up to date. It should say now, not soon. Blue links in search also. So that's just the organic search results. I know also using AMP if that's available. And AMP pages are really just web pages, right? So it's AMP HTML plus CSS. There's no one-off JavaScript. Instead, custom elements, web components, and sandbox AMP iframes that can still do anything. So if you want to do something more advanced, you can do it in an iframe. And the other component of it is the AMP open source library. So it's the same everywhere. You cannot host it on your own. It comes from a CDN. It's the same URL on every AMP page. So it's highly cacheable. And we can control every week what's on it. We can deploy bug fixes really quickly, updates really quickly. So it's an evergreen library. It defines behaviors for custom elements and then manages rendering and resource loading to optimize performance. And now you're probably thinking, wait, no JavaScript. Yeah, we had to take away some of the nice things. I know that's super sad, but there are some reasons for this. There are three sources of speed here. The first source is the format. Second source is caching. The third is pre-rendering. Now let's go into each of them briefly. Source number one is the AMP HTML format. And so if you look at the average mobile site, we already did that. It's really slow somewhere in the back. Now, if you hand tune your site, you can be winning the race, right? If you know what you're doing and hand tune your site and spend months and months of development, you can build an amazing website. An AMP would probably be, second or third place in some cases. But the key here is that we can do it at scale. The key is that you don't need to be a web performance guru in order to do it. So we can do it at scale with lots and lots of pages. And in fact, on an AMP page, you only require a single HTTP request to lay out and load the entire environment. And to this day, a single HTTP request with the exception of web fonts. If you're using web font, that's your own fault. But everything else only requires a single request. We force you to inline your CSS, and we force you to keep it below 50 kilobytes. Otherwise, you will not add it. We also force you to only use GPU optimizable animations. So that means you can only use right now transform and opacity jacking. Sure, there are certain things you can do, but the reason is that only those ones are actually GPU accelerated in most modern browsers. And we also make sure that, and you don't have to manage this is the AMP library done, but we're doing a lot of layout and style recall batching. So we make sure that the style calculation of the page is very, very efficient. In fact, we only require right now 2 style calculations during a typical page load, and sometimes even just 1. All of the scripts on the page are asynchronous. This is also super important. So all of the scripts that you load that come from the AMP library have an async tag. And so they render at the same time, they load at the same time. In fact, when they come from the AMP cache, they're also using HTTP2. So all of this multiplexed. And now this is the key. AMP, because it uses that web components framework, and because it restricts what you can do in AMP, we have a static layout system in AMP that we control, which means that each static element has a predefined size. And if you do just a normal image, you can give it just no size, and it's a 1 pixel image at first, and then it will just load, and push down the content below. Right? That will trigger a relayout every time a new block of the image comes in. But in AMP, you can't do that. In AMP, on the first request, we know exactly how the page will look like, even without any external assets loaded. So extended component downloads do not block page load. That's part of it. The page is completely layouted to the first request. And then third-party JS only allowed in sandbox iframes. And now, because we have this static layouting system, we can do resource prioritization. We know what requests come in and go out. So we can optimize everything in the first viewport, everything that's actually really important. So for instance, one thing we do, and this is probably strange coming from Google, because we make most of our money with ads, but we think ads is frankly not the most important content on the page. Right? It's not why you're going to that page. So probably the content should load before the ad, which is what AMP is doing. Okay, speed source number 2, caching. First of all, caching brings content closer to users. That's clear. I mean, there are actually going to be a multitude of caches. The first cache I've launched is the Google AMP cache. It's basically like a CDN that automatically caches all of your pages and then makes them available for the publisher. So if you go to an AMP page from a platform like Bing or Google, it will not go to the origin domain, but it will load your page from the optimized cache instead. And we're using the same infrastructure that Google Search uses. So all of the edge network around the world. This is a very expensive setup, and we're giving it to you for free. So it's actually quite beneficial to most. But the key thing is not only that it works like a CDN. The key thing is the speed source number 3, which is pre-rendering. The pre-rendering is what really makes those pages feel like instant loading. It's where we're cheating efficiently. What we can do because of the static layouting system is if you search for something like Obama, anything newsworthy, and you see the carousel in Google Search, we actually preload and pre-render, I think, the first 5 or so documents at the same time. And that's usually hugely expensive. and problematic because it can be a very long page with lots of resources. But we only do a single request, right? We tell AMP, don't load anything unnecessary. Only load the content. Only load the thing that actually makes the experience fast. And the first viewport. So we can do that at scale for a multitude of documents at the same time because it's very cheap for us. The other thing, and this is not mentioned on the slide, but it's actually really important, is privacy. And so if we did that with normal web content, if we did that with any kind of iframe, and you're searching for diarrhea, right? And which is usually a very embarrassing topic. So you search for diarrhea, and we preload 5 of those websites that come out. All of those websites can trigger that as page load, can write a cookie, an ad cookie, tracking cookie, saying you search for diarrhea, and can track it forever and give you ads about diarrhea for all your life, right? Even if you never clicked on it. That's not good. So we prevent that. By going through the cache, the actual site will never see a pre-rendered event. So only when you actually click on it, we will tell the page and the analytics on the page, yes, that user actually looks at your page. That's another really important point in my opinion. So these sources of speed in the AMP library. Probably the most effective one being the cache static layout system. We'll now fix the first point. So no loading, non-responsive COM anymore. The first hop is actually really fast now. But what about missing device capabilities? As I told you, I mean, in AMP, you have some restrictions, like it's really mostly for static content, not so much for dynamic pages that require lots of JavaScript. So how about the second solution? If you look at this capability axis, and this is the sign that I made for native apps here, right? Native apps by far outweigh the web when it comes to capabilities, and especially timely capabilities, because they don't have to follow any standardization process. They just do things, right? They operate on a scale that's much quicker because it's not really a fair comparison. Now, however, if you add another axis, which is where we are shining, is the reach. The web is actually accessible everywhere, in every browser, on every device, without any install. So we have dramatic reach compared to native apps. Now, I'm not sure what happened here, but okay. Now, how do we get to where to higher on the capability axis? Right? So what we ultimately want is kind of this. We want to be in that spot over there where we have both dimensions. So how do we get there? Well, first, we need reliability. Second, we need push notifications. Third, on-screen access. Fourth, simple sign-in. And then fifth, one-tap checkout. Those 5, in my opinion, are the most important things that native apps have. So let's start with number 1, this downsort. Now, it's a cute downsort, but you might not want to see it that often, right? Now, that's a bad offline source. When you add something to the user's home screen, you really don't want to see that thing, right? It's fine to occasionally see it in the browser, but if the user adds it to the home screen, he wants to have a reliable experience. So service workers do this. Service workers enable reliability. What if we didn't need to traverse network every time? So this is what service workers do. After the first visit, the site can be reliable. And then what happens is the service worker works like a client-side proxy. So it sits between your website and the web server. And it's like a web worker. It is all just JavaScript. So it's a script file. You write a bunch of JavaScript. And so you have events in there that say, okay, well, you can be informed every time a request comes in from the browser, saying, hey, that browser right now wants to load that image from your server. Is that okay? And so you can say, yes, it's okay, just forward to the server. Or you can say, actually, wait, I'm going to cache that image first, and then I'm going to use the cached version, and then later on grab a new copy. So you can implement all the workflows and do a completely reliable offline experience with bidirectional syncing. You can go very simple or as crazy as you want. And the most important pattern here is the application shell pattern. And it's something that everyone who's worked in the native world knows about, because this is how native apps work. With native apps, the actual install file is including the application shell, all the UI components, all of the layout, all of the views that are required to display the app. And then data is only getting synced from the server, right? So the content is coming in when it populates the view. So with Service Worker, you can cache that shell, and it loads instantly on repeated visits. And then web push notifications, something we recently added to the Service Worker. Because, and that's the cool thing, it's actually built from Service Workers. You know, we can only do this with Service Workers because the Service Worker is independent from your web page. Even when your web page doesn't run, the Service Worker can spin up and handle a push notification and show it to the user without the browser being open, without the tab being open. So that's a really nice new feature. And yes, and then it displays as push notification. Add to home screen, another thing. So this was actually very tricky before, but now we get this little install banner at the bottom that prompts you to add something to the home screen. And so it is added to the home screen. And before, you needed to go to the context menu, and it was very cumbersome to do that. Almost nobody did. And so now, if you have a Service Worker and your site is running on HTTPS, we're actually reasonably happy with that. And so Chrome used that as a signal to show that add to home screen pattern and allow users to add to home screen. Now you have, in order to do that, you have to add a web manifest. To add that manifest, the manifest includes a few properties of how your splash screen should look like, how your icon should look like. And then, yeah, I showed that already, but it looks a bit like that, where you get this little banner at the bottom. So what are the latest problems we're solving? Those are things that have been around for a couple of months. The latest problems is sign-in, for instance. Sign-in is a really big pain point for users. In fact, 54% of users will quit before doing yet another sign-up. And 92% of users will give up if they don't remember a username or password. So if you think anyone ever clicks the forget password link, then think again. Now, we're fixing this with the Credential Manager API. That allows you to sign in way more easily. In fact, it allows you to have users save their info for easy access later. And then first-time users get a prompt to save the login credentials to an integrated browser password manager. In our case, in Chrome's case, that's SmartLock, but this would work in any browser with their own password implementation. And then for returning users, they can get automatically signed in without having to type in a password. And the cool thing is this is not just autocomplete, right? Because that already works. No. In fact, if you do this experience right, the user on subsequent visits never gets to see the password form and the login form. Because we can capture that signal before ever showing that form. We know that we have that capability before showing the form. So it works just automatically. Now with checkout, we also have a problem. With e-commerce, too many fields lead up to 97% of checkout pattern. That's really bad. That means 97% of the people who want to buy something in the end don't. And we want to buy stuff. So no one loves typing on a mobile keyboard for a good reason. What do we do here? The payment request API. It's a standardized API that the WCC worked on to standardize payments across all web browsers. And it then can use existing native payment methods. So it leverages autofill to pre-populate user information. The user can click buy now, it's a single page with everything filled out, and then you can tap to enable checkout in one step with either credit card info or, in our case, Android Pay. And if you do this the right way, it really is a 1 or 2 tap checkout process. So now to the hard part. Which to choose? On one hand, you have AMP, and we've done some case studies, for instance, with the Washington Post. They said they had a dramatically better user experience with AMP. Over 1,000 AMP articles are now published per day on their end. The load times now average
at 400 milliseconds, which is insane, which is an 88% improvement over traditional mobile. And then it also leads to higher reader loyalty and retention. So for those users who read stories published with AMP, more returning within 7 days, which is an increase of 23%. Now that's great, but what about progressive web apps? Housing.com, for instance, they said that that really dramatically increased engagement. In fact, by 38% in conversions, which is huge, and then 30% in page level performance. And then Flipkart, which is basically the Amazon of India, they said even better now. They said 10 times more time spent on their website with progressive web app, 10 times lower data usage, of course, because the service worker, because the app share is already there, and then 70% greater conversion rate among those that are already committed and engaged and have it on their home screen. So great numbers in both cases. So you have AMP on one side, which gives you instant delivery, optimized discovery, no user scripts on the other side, right? So no JavaScript that you can write. And really only mostly good for static content. And on the other side, you have installability and all the other advanced web platform features that are not yet in AMP. App-like features, right? Then slower delivery though, because again, the service worker is important. The service worker only comes at play at the second time the page is loaded. But unfortunately, most of the time, it's the first impression that counts. Right? If people cannot arrive on your page for the first time, they will never arrive at your page. And then it's not really easily embedded, so it doesn't really have the whole caching infrastructure. You can't really make it feel instant. So is it going to be instant first load or native like app? So how about both? So how do we go from AMP to progressive web app? And now we get to the technical part of this. Level 1, and this is 5 levels in total. Level 1 is build a great AMP experience, because AMP is good for leave nodes. AMP is for that Facebook link or Pinterest link, for the first hop of your page. So there's a lot of components already. We'll give you a lot of built-in sugar, even though you can't use any JavaScript. There's a lot of built-in stuff already that you can use. Want to embed YouTube, you can do that. Right? There's an AMP YouTube right there. So there's a growing list of components. I think we have over 50 components now for all sorts of things, for analytics, for ad networks, for everything imaginable. And if there's something not around, then we're usually pretty happy to fix it. So you usually find something, and then you need to decide, again, do you want to publish just one page, which is the AMP page, or do you want to do a paired node where you have a desktop website, for instance, and then you have an AMP website that are paired. Also, the validation is key. So you can add hash development equals 1 to the URL of your page, and then the AMP library will validate in Chrome DevTools and gives you the validation results. You can also do it more easily on validator.ampro.org, and that will also spit out the result. Basically, it's like the same, and there's also a browser extension you can install that is even easier because it shows you right away green or red. And important thing, if your AMP page doesn't validate, right, we cannot be sure that your page is fast. There could be any crazy JavaScript on it or something. And so that page will never appear as AMP on those platforms. It will never be cached by the Google AMP cache. So you can still load it on your own domain, but you won't get most of the benefits of AMP. How about AMP for desktop? It's called accelerated mobile pages, which is a little bit unfortunate. But yes, AMP for desktop is absolutely a thing. You can totally do that. In fact, responsive design is built into AMP. We designed it from the from the beginning with responsiveness in mind. So you have the layout property to render elements responsively. This is actually quite tricky sometimes in HTML in order to do certain things like that with an image, for instance. Image responsive, for instance, has a fixed aspect ratio and it resizes to its parent. But you have fixed height, fill. All of those are really easy ways. Those are attributes to add to your tags. And then you can also use source-set, which we polyfill across all browsers, so it works across all browsers, to do responsive art direction, images in art direction. So So you load different images for retina, for non-retina, for different form factors and different widths of the viewport. And then you also have, which I really like, element media queries. So usually media queries work in CSS, right? So you define them in your style sheet and then you hide entire sections of your page or not. But we allow you to add media queries to your elements and then hide elements or show elements based on the attributes. So for one-off things, for one-off content, that's actually really nice. Let's get working. How do we actually build something like that? And the good news is I built something like that. So it turns out the AMP-project.org homepage is completely AMP itself because we like eating our own dog food. So we're going to build that menu here. And that menu, as you can see, is a sidebar. It slides in, slides out, and it has sort of an accordion drop-down. So first step is actually pretty easy. We find a component called AMP-sidebar. So next, there's the AMP-sidebar component. It's actually pretty straightforward. It's just a component with a button inside it, and then we have all sorts of other HTML in there, a list. And then there's a tab, an on attribute that you can see here, and then also the button outside of it. An on attribute that works like a dynamic event that says, okay, on tab, please show that sidebar with the name of toggle. That's all we need to do sidebar. First problem solved. What about drop down? It turns out there's no AMP drop down. All right. What do we do about drop down? We can't use any JavaScript, right? There's an AMP accordion though. How about AMP accordion? Let's have a look. So we also built a site called AMP by example where you can check out how things could look like. And so you see, okay, this is basically a straightforward accordion. And it works like an accordion. But scroll to the bottom, you see that you can also use it with just one entry, and it sort of works like a drop-down. I mean, of course, it pushes content down in this scenario, but maybe we can style it differently. And so sometimes you have to be creative. And this is exactly what I did here. I just gave it a fixed height, and I made it work like a drop-down. So now you get that drop-down in toggle to change the language. And it's an accordion that's just styled differently. And that sometimes you just have to be creative. But then sometimes you also have to be crazy. In my case, on my own website, I wanted to do a more advanced menu like that one. And I decided to just do it all in CSS. So there's actually a lot of clever CSS hacks that you can use that are often forgotten. For instance, in this case, I have a label, and this label is actually the hamburger menu. Doesn't use any images, it's just these bands, and it's a label. So this label is the label for an input that's actually invisible. You can't see that input. And so that input, when you click that label, that input gets checked and unchecked. And then I have a adjacent selector in CSS that says, for the element after that checkbox, when it's checked, either hide or display. So it gives me a toggle on that hamburger menu in pure CSS. So quite a nice way to do things like that. So yeah, okay, we did all that, right? With just a couple lines of code. No JavaScript. Okay. How about optimizations? So one advice is only include the AMP scripts needed for the page tags. It's kind of obvious, but so there's a lot of tags that you can use, all those load asynchronously, but it's still overhead. And only load the CSS you need for a given page. Don't just inline it all on every page because you have the 50 kilobyte limit. And you're gonna breach that limit otherwise. And more examples for AMP you will find AMP specifically on ampbyexample.com. So level 2, accelerate subsequent loads with service worker. As I said, service worker comes into play on the second request. So we can use this library like a service worker precache that makes it quite easy. In this case, you just, in your build script configuration, you can integrate it and you say, okay, those files here and those folders, please make them available offline. Cache all files from this URL as well on request during the runtime of the app when you discover them. And this is just an implementation step. And then On the AMP side of things, you would usually require JavaScript. But we abstracted it. We added a AMP install service worker tag. So if you add that tag to your page, it installs the service worker from your origin. Now the cool thing is that this also works if your AMP site, AMP page, is actually served from the AMP cache. So even if it's not running on your origin, this will install the service worker from your origin. And so you can bootstrap a lot of things that way. So on the second click, when you land on the origin, that thing comes into play. So you can see that now in action with the library. So in the application tab in Chrome DevTools, you don't see the tab bar here. You can see, okay, there's a service worker. It's actually installed and it's running. And so I can also go to the cache storage tab on the site and see, okay, all those resources are in fact cached. And now all those AMP libraries are also cached. So if I want to try it out now, I can just hit the offline toggle in the service worker panel and reload the page and see, okay, it actually works. I mean, you don't get to see my face anymore because it's a YouTube video. Of course, we don't catch the YouTube video. But the entire site, all the navigation, all the docs are actually now available offline. And it was really not that hard. It was just a small configuration and a library. But let's get real. If you want to do this yourself, I'm going to walk quite quickly through those. But if you want to do it yourself, you can do that too. I just want to make you feel that it's not actually that scary, because the API is designed quite well. So this is the service worker. In the service worker, again, you get events. And so, for instance, you get the install event, where you can say things like, okay, take over the old service worker immediately if you get a new service worker, and then wait with finishing until you open a new cache, and then in that cache, you add a lot of static resources to it first for the application shell. So that's that happen. And then the next step is to activate the service worker. After install comes the activation of the service worker. In which case you don't really need to do much. In this case, I just call a line that says, whatever tab is currently open, grab it right away. I'm the service worker for this tab now. And then this is the most important thing, which is intercepting requests. What you do here is there's a fetch event. And so in the fetch event, you call event respond with, which says, okay, browser, I'm going to take over now. So what I'm doing here is I'm opening that cache that I set up earlier. And then I'm seeing if there's a cached version of the URL in there. Does it match with the cache, the request URL? If yes, then I'm going to, okay, first I'm going to then set up a fetch promise where just in case I fetch it again because the resource could have been updated. And when I have fetched it again, I'm going to put it in the cache again. But at the same time, I'm going to return the response directly if there's already one in the cache. And there's none in the cache, I'm just returning that fetch promise, which means when the promise finishes, I will still have the resource cached and responded to the browser. So that means either you will get an instant response, or you will get the first time you get the response from the server, but it's cached at the same time. That's a very easy implementation of fetch. Now, you can learn much more about this. This can get way more complicated. There's a lot of strategies to build offline apps. And my colleague Jake has built not only a very awesome course, which is free, on Udacity.com, called Offline Web Applications. I would just Google it and not type down that URL. I think it's easier. And coincidentally, it's also very funny, so it's very entertaining too. Level 3 is adding a web manifest to trigger add to home screen app. Again, we're still talking about the AMP page. In this case, we add the manifest. The manifest looks like this, and we talked about it briefly before. So you have a couple of properties in there, background color, theme color, icons for the project. And then you can validate that by going into Chrome DevTools, again going to the application tab, and then hitting manifest. And it shows you what the browser thinks the manifest looks like. So it shows you if all the icons load, if everything looks all right. And you can click on the very right, you can click add to home screen to simulate the add to home screen. And if it fails, if it thinks the manifest is not complete, it will log it out in the console. And so in action, again, it looks like this. So here's the crazy thing, right? Right now, in the first 3 steps, we only talked about AMP. The crazy thing is, you just build a progressive web app without writing a single line of JavaScript on the client. So you add the manifest, your page runs hopefully on HTTPS, your page has a service worker, it's available offline. All of that you can do by just using AMP. But however, we can go further than that. And so in level 4, we enhance those AMP pages and service worker pages. In this case, for instance, let's assume that every page that I'm following my own rules. I'm actually inlining the CSS over and over and over on my own page. So in fact, this is what I did before. Now I'm doing it a little bit optimized, but because AMP was inlining of CSS, the typical page header of a page on amp.org was 43 kilobytes. And so I cached about 100 docs. And so 100 by 43 is about 4.3 megabytes of additional clutter. All of those headers are the same. So why do we need to cache them all? And what if we could only cache the body and then merge with the header on requests? Because the service worker, we can write any JavaScript we want, really. But the strategy is get the text response of the page in the service worker, then cache just the body, and then prepare a small template that makes up the rest before the body. And then on subsequent client requests, stitch together the responses to recreate a full page. And so the first step, again, is to use a special template, which is just the head. So we get a template that is just the head of the page, which is that code right here. Now the second is, yes, this one is where we, I'm not sure why the title is gone, but this is where we do the next step, where on every incoming request, this is the fetch event, right? Where on every incoming request, if we see it's a document, we actually regex the crap out of it. Now, please don't do this at home. Never regex HTML, it's a bad idea. You should probably use a DOM parser and do it the correct way. But just for demonstration purposes, because this is a slide deck, and I don't have unlimited space, I'm regexing it here. And so I'm stripping out just the body of that page. And only the body gets stored in the cache. And then finally, and this is an important bit, when the browser requests a page, we're going to stitch it back together. We're going to get the template that we already cached, which is just the header of the page. It's just the text from the cache. And then we're going to stitch it back together by just doing string concatenation. And this is the result. We'll just make the cache much smaller, which is really important on low constrained environments. Now, this sounds okay, but I want to be a bit more fancy. You know, like, okay, I kind of had a little bit of nostalgia, and I went to this cool page called Rainbow Scripts. You know, reminds me of my early days of coding. And in fact, yeah, I found this amazing cursor animation that I really think every page benefits from. Right? I mean, it's clear that it's beneficial to my experience. So, and then I remembered, okay, I mean, yeah, shit, we can't use any JavaScript. So what do we do? I mean, this requires crazy DHTML magic. But we're stitching together things in the service worker. So, yeah, no JavaScript, but what if we add some random stuff that AMP doesn't like, that doesn't validate in the service worker? So, let's try that. What happens then? Let's read up the page. Oh, yes. Crazy. Okay, so first of all, oh, what have I done? It's not good. Second, this actually works. This works because the Google AMP cache will see and cache the normal AMP page. It has no concept of the service worker. It doesn't know about the service worker. And so consumers will see the AMP page on first click because it's coming from the cache. But then on every second click, if they click out to another article and it goes to your origin then, the service worker will take over
Everything will be instantly cached, and you can extend it with all sorts of craziness. Hopefully not that mouse cursor, but maybe something that's actually worthwhile. And you can go one step further than that with the same technique, actually. Level 5 is completely reroute in the service worker to a progressive web app. So what you're doing now is this here. Your app install service worker, you pre-boot the progressive web app. So you cache the application shell of the progressive web app. And then once the user clicks on another link on that page, it redirects to the progressive web app. So like the technique before, in this case, we don't just stitch things together, but we take over the entire navigation. We just say, yeah, that user requested an AMP page, but I'm going to give them the full experience. And so the Washington Post actually does that. The Washington Post bootstraps their PWA, and then later on in the bottom, if you get a call to action to check out their PWA, it then loads the PWA. So this works by hijacking all navigation, serving the PWA shell in. The PWA shell initializes a Shadowline-based AMP viewer, and then the originally requested AMP document is fetched via XHR. On subsequent navigation, it uses history push state in XHR to navigate within the AMP viewer only. So there's an example, an early example in our GitHub project how to do this, but we have a much better one coming up. And if you're interested in that pattern, I'm going to talk much more about it next week on Friday at Chrome Dev Summit. And it's live streamed and it's free. So might not be in your time zone, but and the videos are going to be available afterwards too. I'm going to talk exactly about that pattern in detail. Phew. Okay, that was a lot of stuff. I know, but and I mean, if you're like me, you're going to forget 90% of it. So, in order to not forget and refresh your memory again, go to ampro.org/docs. You will have to see my face again. That's the unfortunate news, but you will learn much more about AMP. And if you want to learn more about progressive web apps, you go to developers.google.com/web, where we talk about web development in general, but also all those new features you just saw about the credential management API, web payments. I just touched those things because there's much to talk about. It's actually a lot to talk about. But yeah, we write about all of them. And finally, we have a lot of videos on github.com/Chrome developers. We have a Slack channel where we try to answer all of your questions. If you haven't seen it, chromiumdev.slack.com. You can always tweet us. You can also tweet me if you want to. And now we just made those two very slow turtles, right? We put them in the right environment. And in the right environment, the turtle can be really fast. Thanks. So we have a few, I don't know, are there any questions? I think we have a few minutes for questions, if anyone has questions.
So,
yes.
Are the links inside an AMP page linking to the actual site, like the canonical URL that you would have?
The question is, are the links on an AMP page linking, on the page you see for the first time, linking to the actual origin? Yes.
Okay.
Yes, so the first click is always going to the AMP cache, but then every other click, every link on your page is going to the origin.
Will the AMP cache always have to be posted by Google?
No, absolutely not. So the first AMP cache was provided by Google, but we have open sourced all of the specifications for the cache and made them available. So there's going to be a number of caches provided by other companies in the future.
Because it's a very big ask to work.
Yeah, I mean, it's a lot of work. I mean, I didn't.
No, it's a very big ask for, because basically you're hosting the content, or Google is hosting the content.
Yeah, this is a common question that we're getting, a common concern.
Yeah.
Right? Basically, people saying, "Hey, Google can do everything with our content now." Right? We give them the keys to our content by doing that. But the important thing is that we have cache guidelines that we open source that are freely available for everyone to check out, and those guidelines specifically say are basically written like a contract, and they say that we can do optimizations like image optimization and loading optimizations, but we can never ever mess with your content. So
a cache is not allowed to insert ads or reformat your page or do anything with it, because it is your page. It should look like your page. The technicality behind it, how we cache it, that's a different story. But we want to make it look like your page. You should get all the monetization from it, all the analytics from it. But again, Google will not be the only cache. There will be more caches. Does that answer your question?
Yeah.
Okay.
Are the AMP components, is this an open source project? So can you like pull requests new components somehow?
So the question is it an open source project? It is completely open source. All of it is open source. All the way on github.com/AmpHTML. I think /AMP project and then /AmpHTML. All of it is open source. This is actually how we work. We just, please, if you see something that you would like, or if you discover a bug, please just file an issue on GitHub, and the chance is very likely that we'll respond in a day. All right. More questions?
Nobody else?
No one else? Okay, then.
Because you just mentioned monetization at the beginning. Could you just give some pointers about it, or how will this?
Yeah, there's a few important aspects about monetization. Obviously, an important topic for publishers. One is that the ads work, frankly. And so from the get-go, we've been working, and we're still working on enabling all sorts of ad vendors to support AMP. So we have an AMP ad tag in AMP that supports, I think, almost 50 different ad vendors now, all of the popular ad vendors. And we make it very easy for new ad vendors to support AMP. So that's one thing. There's a couple of ads that we don't support because, frankly, we think they're annoying. For instance, pop-ups, right? Or full screen interstitials. Those are just ads that are frankly shit. And you don't want to see them, so we don't want to see them. But in general, we're trying to be very reasonable about it and allow everything that is not completely detrimental to user experience. So that's one, ads. Second one is Paywall. So some publishers require login access to monetize their pages. We do allow that as well. We have an AMP access plugin that allows you to do both client-side and server-side access for AMP pages. That's the second. And the third, in order to monitor how monetization works, they need really good analytics. So we have created a AMP analytics component that plugs into all sorts of analytics libraries and creates a uniform standard for things like click tracking in order to do all of that as well. So we care a lot about monetization now. It only works, in fact, if publishers report us that those pages monetize well. Everyone happy?
Service workers, do they work on every platform, or is this like Chrome, Android?
Service workers do not work yet on every platform. Right now, they're supported by, I hope I'm doing this right, but right now they're supported by Chrome, Opera, and Firefox. And Microsoft has indicated that, I think that is under consideration, so I think it's very likely that we'll see it in Edge soonish. And like always, there's no word for Safari. So if you want it in Safari, please just annoy Apple as much as you can. All right, thank you. Yeah, please grab me outside if you have any more questions on